In this video, we will talk about electrostatics and charging by contact. Stated briefly, electrostatics is the branch of physics that deals with static electricity. To get started, let's suspend a very light metal-coated ball by an insulating string to a stand, and let's get a charged ebonite rod and put its charged end in contact with the ball. The ebonite rod and the ball repel each other. What happens is that when we put the charged end of the ebonite rod in contact with the ball, some electrons leave the negatively charged end of the ebonite rod and move to the metal ball initially neutral. Thus, the metal ball becomes negatively charged like the ebonite rod, and therefore they repel each other. We can repeat the same experiment with a glass rod instead of the ebonite rod. The glass rod and the ball also repel each other. What happens is that when we put the charged end of the glass rod in contact with the ball, some electrons leave the neutral metal ball and move to the positively charged end of the glass rod. Thus, the metal ball becomes positively charged like the glass rod, and therefore they repel each other. This phenomenon is called charging by contact or electrification by contact. Note that charging by contact is due to a transfer of electrons. Now let's talk about the electroscope, which is a device used to detect the presence of electric charges. As the figures show, some electroscopes consist of a vertical metal rod, from the end of which hang two parallel thin and flexible leaves of gold or aluminum, protected in an enclosed insulating container. A metal ball or disc terminal is attached to the top of the rod, where the charge to be tested is applied. We will start with this experiment. We bring a charged ebonite rod and put the charged end of the rod in contact with the ball of the electroscope. The leaves of the electroscope spread apart. If we touch the ball of the electroscope afterward, the leaves of the electroscope revert back to their initial position. Let's explain what happened. When we put the charged ebonite rod end in contact with the ball of the electroscope, some of the excess electrons transfer from the charged ebonite rod end and flow through the ball and metal rod to the leaves. Since the leaves receive the same sign charge that is negative in this case, because they gained electrons, they repel each other and thus spread apart. The electroscope is said to be charged. When we touch the ball of the negatively charged electroscope, the excess electrons move from the leaves, flow through the metal rod and ball, and transfer to the human body, which makes the leaves electrically neutral. Their weight makes them revert back to their initial position. The electroscope is discharged. We can repeat the same experiment with a glass rod instead of the ebonite rod. The leaves of the electroscope also spread apart. Again, if we touch the ball of the electroscope afterward, the leaves of the electroscope collapse. This is because when we put the charged glass rod end in contact with the ball of the electroscope, some electrons flow from the leaves through the metal rod and ball and transfer to the charged glass rod end. Since the leaves get the same sign charge that is positive in this case because they lost electrons, they repel each other and thus spread apart. The electroscope is charged. When we touch the ball of the positively charged electroscope, some electrons transfer from the human body through the metal ball and rod and then into the leaves, which become electrically neutral. Their weight makes them revert back to their initial position. The electroscope is discharged. Note that the electric charge carried by a charged body is given by the formula Q equals plus or minus NE, where N is a whole number and E is the elementary charge. Thus, the absolute value of Q equals NE. Also note that during charging, the total electric charge is conserved. And this is all for this video. Thank you for watching.